Humans are the most common and widespread species of primate. A great ape characterized by their bipedalism and high intelligence, humans have a large brain and resulting cognitive skills that enable them to thrive in varied environment. Humans are highly social and tend to live in complex social structures composed of many cooperating and competing groups, from families and kinship networks to political states. As such, social interactions between humans have established a wide variety of values, social norms, languages, and rituals, each of which bolsters human society. As populations became larger and denser, forms of governance developed within and between communities, and a large number of civilizations have risen and fallen. Humans have continued to expand, with a global population of over 8 billion as of 2023. Genes and the environment influence human biological variation in visible characteristics, physiology, mental abilities, body size, and lifespan. Though humans vary in many traits, any two humans are at least 99% genetically similar. Humans can survive for up to 8 weeks without food and 3 or 4 days without water. Humans are generally diurnal, sleeping on average 7 to 9 hours per day. Childbirth is dangerous, with a high risk of complications and death. This has allowed great technological advancements and complex tool development to be possible through complex reasoning and the transmission of knowledge to subsequent generations. Long-distance trade routes might have led to cultural explosions and resource distribution that gave humans an advantage over other similar species. Human evolution was not a simple linear or branched progression but involved interbreeding between related species. Genomic research has shown that hybridization between substantially diverged lineages was common in human evolution. Access to food surplus led to the formation of permanent human settlements, the domestication of animals and the use of metal tools for the first time in history. Agriculture and sedentary lifestyle led to the emergence of early civilizations. Early human settlements were dependent on proximity to water and, depending on the lifestyle, other natural resources used for subsistence, such as populations of animal prey for hunting and arable land for growing crops and grazing livestock. Humans are one of the most adaptable species, despite having a low or narrow tolerance for many of the Earth's extreme environments. Through advanced tools, humans have been able to extend their tolerance to a wide variety of temperatures, humidity, and altitudes. As a result, humans are a cosmopolitan species found in almost all regions of the world, including tropical rainforest, arid desert, extremely cold Arctic regions, and heavily polluted cities. In comparison, most other species are confined to a few geographical areas by their limited adaptability. The human population is not, however, uniformly distributed on the Earth's surface, because the population density varies from one region to another, and large stretches of surface are almost completely uninhabited, like Antarctica and vast swathes of the ocean. Humans have had a dramatic effect on the environment. They are apex predators, being rarely preyed upon by other species. Human population growth, industrialization, land development, overconsumption and combustion of fossil fuels have led to environmental destruction and pollution that significantly contributes to the ongoing mass extinction of other forms of life. Humans have about 2 million sweat glands spread over their entire bodies, many more than chimpanzees, whose sweat glands are scarce and are mainly located on the palm of the hand and on the soles of the feet.
In the context of human biological populations, demographic analysis uses administrative records to develop an independent estimate of the population. Demographic analysis estimates are often considered a reliable standard for judging the accuracy of the census information gathered at any time. In the labor force, demographic analysis is used to estimate sizes and flows of populations of workers. In population ecology, the focus is on the birth, death, migration and immigration of individuals in a population of living organisms. Alternatively, in social human sciences could involve movement of firms and institutional forms.
patient demographics form the core of the data for any medical institution, such as patient and emergency contact information and patient medical record data. They allow for the identification of a patient and his categorization into categories for the purpose of statistical analysis. Formal demography limits its object of study to the measurement of population processes, while the broader field of social demography or population studies also analyzes the relationships between economic, social, institutional, cultural, and biological processes influencing a population.
To do this, there needs to be an understanding of how they are calculated and the questions they answer, which are included in these four concepts: population change, standardization of population numbers, the demographic bookkeeping equation, and population composition.
A census is the other common direct method of collecting demographic data. A census is usually conducted by a national government and attempts to enumerate every person in a country. In contrast to vital statistics data, which are typically collected continuously and summarized on an annual basis, censuses typically occur only every 10 years or so, and thus are not usually the best source of data on births and deaths.
In countries in which the vital registration system may be incomplete, the censuses are also used as a direct source of information about fertility and mortality. For example, the censuses of the People's Republic of China gather information on births and deaths that occurred in the 18 months immediately preceding the census. Indirect methods of collecting data are required in countries and periods where full data are not available, such as is the case in much of the developing world, and most of historical demography. One of these techniques in contemporary demography is the sister method, where survey researchers ask women how many of their sisters have died or had children and at what age.
With these surveys, researchers can then indirectly estimate birth or death rates for the entire population. Other indirect methods in contemporary demography include asking people about siblings, parents, and children. Other indirect methods are necessary in historical demography.
As the samples have been drawn in a nationally representative way, inferences can be drawn from these studies about the differences between four distinct generations of British people in terms of their health, education, attitudes, childbearing and employment patterns. Population change is analyzed by measuring the change between one population size to another. Global population continues to rise, which makes population change an essential component to demographics. This is calculated by taking one population size minus the population size in an earlier census.
The best way of measuring population change is using the intercensal percentage change. The intercensal percentage change is the absolute change in population between the censuses divided by the population size in the earlier census. Next, multiply this 100-fold to receive a percentage. For there to be a significant comparison, numbers must be altered for the size of the population that is under study. For example, the fertility rate is calculated as the ratio of the number of births to women of childbearing age to the total number of women in this age range.
This is because developed countries have proportionally more older people, who are more likely to die in a given year, so that the overall mortality rate can be higher even if the mortality rate at any given age is lower. A more complete picture of mortality is given by a life table, which summarizes mortality separately at each age.